I guess we can start. So let's quickly review what we have done, and I'm pretty sure we can finish this chapter. So just to quickly remind what I've been doing, it's kind of a math problem, right? It's an optimization problem. And the way we use this optimization problem is to think how a consumer try to buy something, right? And based on the constraint, right? It's resources allocation, right? He has an objective is utility, right? The constraint he faces is the budget, right? He consumed the price are given, what can be bought is given, and the preference is given from give you the utility function, right? And that is the question. And then we will derive a dual problem, a cost management problem, which we will use it in the firm as well. And then we'll talk about customer service. We'll finish everything here. These are all basic, right? Because of for marketing or for whatever decision, right? Usually we assume the classical method is maximizing some utility or maximizing some objective, right? Which is same as firm, right? Firm is maximizing profit, right? So we are doing some kind of operation that is involving optimization, right? And some of you may ask, right, why we care about maximization, right? Because utility can't be observed, right? But if you read textbook, they will say, if you follow idea that people have preference, I mean they're rational, with the transitive and complete, and continuous and some monotone, right? And people are maximizing utility is as if they are choosing the best bundle according to some preference. I think the preference is something that is primary enough that people know how to choose from a set of objects, right? Of course, those people who do experimental would disagree. I mean, they have some deviation, but in general, right, people have some preference is pretty normal, right? Because of course, the preference will be very weird, but in general, that would be satisfy what we want to do. Okay. Just to quickly recap, what we're doing is we already start with the world. We have n different type of bundles, right? And the bundle is perfectly divisible. Okay. And this represented by a vector of numbers. Okay. And this in the two-dimensional world, then will be just a point in this plane. Okay. And we focus on positive quantity. So it's the positive quadrant, is just this area. Okay. And we talk about binary relations, right? And it's complete, right? Either x prefer to y or y prefer to x. And that's transitive, right? If x better than y, y better than x, and x is better than z, right? And we call this rational. And we define what's indifference from the weak preference, and we can also define strong preference or strict preference. Okay. And then we define monotone preference, which is we talk about good rather than bad, right? And also we define continuity, right? Which means that if the strict preference will continue to hold when there's some nearby, right? When x better than y, something nearby x still better than something nearby y. Okay. Oh. And convexity, I think the slide was typo here, right? Is you have two bundle, x better than y, combining the two bundle in whatever way is still strictly better than y. Okay. And we have indifference curve, all right? And why we have different assumption of preference is we want to have this downward sloping convex shaped the indifference curve, right? The assumption that we have monotone, convex, continuous will allow us to draw this indifference curve that you learned in the intermediate micro, if you have joined the class before. Okay. So utility function is we give number to each possible bundle, right? And if possible, then we have utility function. And we know that this is not always possible, right? For example, if not continuous, that's not possible. And the most famous example of non-continuous preference, which usually the case is the lexicographic preference, which we have said before, right? Is you would rank first certain criteria first, disregard of all the other criteria, right? Just remember the leading example is the Shanghai marriage market, where men are evaluated by the income or with the households, right? So and so forth, right? So that would be the case where people fall about lexicographic, right? Or people probably now, the recent case is the new iPhone, right? And some people would always prefer a bigger screen regardless of what, right? No matter the price, right? So you would prefer things in this way, or they always like Apple, whatever, no matter what other they do, right? Or people would like Huawei regardless of what other brand would offer, right? So that would be lexicographic, all right? So it really depends. But so this is the proof for the we did this proof, right? The simple proof for how we prove the existence of utility function if you have continuous and monotone. Okay? And indeed, you read a textbook, they will tell you that you can do away with the monotone. Okay, I mean, if you only need to assume continuous preference can generate continuous utility function. Okay, but that would be a very difficult proof, which is way beyond our class. Okay, but yeah, you can see utility function existence is almost like guaranteed as long as your preference is continuous. Okay? So monotone is not needed, but for business application, monotone is normal. So I don't think you have to worry about we still have this keep this assumption to prove it. Okay, and oh yes, here, right? It's beyond the scope, so we really need not there. Okay, and if our preference is convex, then utility will be quasi-concave. And if you learn optimization theory, quasi-concave is the requirement to get you the second order condition, which we'll talk about today, the guaranteed existence of a unique outcome. But anyway, we will see. Okay. So one key point is marginal utility, which require the utility to be differentiable, and probably why we want to do about this marginal thing, because without this marginal utility, it's hard to characterize equilibrium, right? Because you can find equilibrium, but what property you have depend on differentiability, because you can, when things are differentiable, you can say how the optimal, to characterize the optimal, describe the optimal, you can see how slight changes lead to the changes of the solution or what it looks like. This is very standard technique. No matter what equilibrium you found, you want to do comparative statistics, right? Comparative statistics will tell us the property of the equilibrium, right? So that's why whenever you solve equilibrium, you want to look at comparative statistics. The same when you talk about game theory, right? You solve the next equilibrium later, we'll define, solve some equilibrium concept. We really want to make some change in the environment and to see how the equilibrium changes and have some idea how it looks like, right? But in this particular case, we want to see marginal utilities defined as if I consume a slightly one more unit of I or less one with I, how my utility changes. And I don't worry about whether I do more or do less because I assume my utility is defensible. So at the very small quantity, whether I increase or decrease the same. So that would be the meaning of marginal utility. Okay. And because we will assume that usually assume interior solution, So every quantity will consume a positive quantity. So we can always decrease and increase without any issue. Okay. We will involve ourselves for the Lagrangian, not Quantica. So that's why it's always interior thing happen. Okay. So by standard, we will assume that normally, most of the cases we assume utility is diminishing, the marginal utility is diminishing. The second order is always a concave shape. The reason is being that if your utility is not in this way, okay, doesn't satisfy this, you will usually have corner solution, which we hate, right? Because you don't want, if this doesn't satisfy, then likely you will consume one unit, only one single good, and that's sufficient, okay? Because price is constant. So you have infinite quantity, there will be some issue here. So this is the key terms for characterized equilibrium, is what we call the marginal substitution, which we will see again very soon, right? This is saying that if I not consuming one unit of I, okay, how many units of J I need to have to make myself the same as before, okay? This is in terms of you mentally, what is your exchange rate, okay? I take away I from you, okay? How many J I have to give you to make you as same as happy as before, okay? It's internally, you are willing to trade in your head, okay? Suppose this is 4, okay? That means that I take out 1 unit of I from you. I need to give you back 4 units of J to make you as same as happy as before, okay? Of course, this unit change accordingly because of your marginality changes, right? Depend on how much you're consuming for I and J, this will change, right? So that would be a very important number to keep in your mind, okay? And this quantity actually closely related to the graph idea, the indifference curve, right? The indifference curve tells us this marginal substitution, right? Because that's the math behind. And if you look at this graph, let's go back to, sorry, to go back a little bit here, right? This point, 4 and 1, right? And you draw its tangency here. The slope here means the MRS. Okay, if every point is different, okay, and you can see that as you consume the standard concave or convex shape, okay, as you consume more of good one, right, the slope gets flattened, right, the slope getting less steep, right. So you are requiring less unit of x2 to compensate for the loss of x1, because you have more x1, then you kind of saturated, okay. So that it gives us the standard thing we want. Okay? I'm not going to talk about these examples. They're perfect substitutes, perfect complement, or Cobb-Douglas. They're the 3 things that I would recommend if you have time. Sorry, I mean, when you try to derive a model, you start with this example. I mean, Cobb-Douglas, Leontief, or the this Cobb-Douglas or the perfect substitute, with the thing that you start when you try to write any model, that I recommend you write in this way. Okay, that would be something that you start. Okay, now we start back the problem. Okay, formally, is a consumer would face a positive prices for each quantity, and this price is taken to be exogenous fixed. Okay, you can change the model to allow the price to based on what you buy. In case of supply chain or you're a big buyer, the price can change accordingly. But in our baseline model, we assume everyone is price taker. Okay, so the P is exogenous, and the budget is exogenous. Okay, and this is the money is given from somewhere else. Okay, and later when we learn general equilibrium model, you will start with some goods initially. Okay, so the budget depends on what you're choosing. Okay, will change. Okay, but in the current moment, the budget's aligned. So that is something very simple, right? So for the consumers, which the choice is very simple. Given this budget, okay, the budget will tell us this area, okay, will be what the consumer can choose, okay? And he wants to choose the one that will maximize his utility, right? So one way to think is you draw different indifference curve, right? And you pick up the point that is the highest in terms of indifference curve, right? So that would be the easiest way, right? Just maximize, choose the best bundle there. And in terms of math, that would be this problem, right? Maximize based on utility and this solution. Of course, in general, this solution may or may not exist, right? But according to our assumption, where U is continuous, U is quasi-concave, right? Strictly quasi-concave, that would be that we will have solution, okay? So this assumption we have is first, U is continuous, right? Then you always have solution, which we know it already, right? Just some standard math theorem tells us that, okay? And second, when this is strictly quasi-concave, it's a unique, right? The reason is very simple, right? Because strictly quasi-concave means that when you combine two different bundles, it's strictly better, right? So if there are two solutions, you can always combine it, okay? So that's why you can always have one solution. So that is trivial, I hope, to you. And then you can see the way of proof is we often use in this consumer theory is proof by contradiction, right? Suppose there are two solutions and then you figure out the contradiction there, okay? But I'm not going to talk about because I guess very few of you are actually doing proof anyway. So I just tell you how we do it. And same, if U is monotone, we'll use up the budget constraint, right? Suppose it's not, then you can always figure out some direction, which is northeast direction to be exact, that would make you high utility without all the budget constraint. So that's why it's always you consume all the thing that's called Wawa's law, okay? Now, probably we stopped this last time. We have the problem, consumer problem. We want to figure out what is the solution and how to interpret it, okay? We assume the existence and there's a unique, right? So what the next is, okay, how does the solution look like? And the solution, which coming from the solving the Lagrangian, which we'll talk about later, we start with the economic intuition first, right? Always, I would recommend, even though you know you're very good at math, you know how to solve it, the first thing is to think about the solution in terms of economic logic, right? Or if you have derived the solution, think about what is the economic behind, right? Because we're econ class, not a math class, okay? So think about what's econ behind. So look at this again. It's the left-hand side is the marginal utility. So marginal rate substitution between I and J. And this is the P over PJ, right? The price ratio. And we call what this is. This is saying if I take away 1 unit of I from you, how many J I need to make you as happy as before? Is your internally, your head, how it changed without talking about money, right? Just utility. There's nothing about budget. It's yourself at the optimal point. That is your trade-off, okay? And the right-hand side is what? The right-hand side is nothing about you. It's about the market. It's about an environment. Where in the market, if you give up 1 unit of J, give 1 unit I, then you sell it, you get PI money back, right? Because the market is always allowed to exchange in this way, right? You can sell what your good I you have, you get PI. How many unit of J you get is over PJ, right? So this is, you give up 1 unit of I, that's how many J you get, okay? And optimal, this will be the same. If not, then you always do the change. Is that clear? That means that you equate the market to yourself, okay? There's no way you can gain from trading, okay? There's no gain of trade, okay? So that is the idea, okay? Is that okay? So that is the optimal condition. And there's no way you can getting better is the bundle that you don't want to trade anymore, all right? That is very normal because you can always trade as long as you want. Is that okay? So, or this is a classical idea of the marginal benefit equal to marginal cost, right? I'm not going to explain that. I think that is clear. If you want to read, you can read that thing. Okay. Already I go to the Lagrangian problem. Okay. If you learn the max optimization subject to equality constraint, the standard thing you learn is Lagrangian. This is calculus, the college level entry calculus. Okay. And what you do, the standard way is, okay, you write the Lagrangian multiplier and linear constraint and do the same, right? Differentiate the object, all your thing you want to optimize, and you Lagrangian multiplier. You solve the system of equations, right? So solving the system actually gives you this guy, okay? And this guy seems to be different from what we have said, right? But let's interpret, as I said, it's good. It's important to interpret what does that mean, okay? The last one comes from the multiplier, says the budget constraint will be holding, right? Which is Wawa's law, nothing new here, right? Wawa's law, there's nothing new. But what about this guy? Okay. This guy requires some explanation. The left-hand side is how much, in terms of utility, you get if you consume one more unit. Okay? And this PI is what? Is if you buy one more unit, how much you pay, right? And multiply lambda. Okay? So what does the lambda mean here? Right? Because this is in terms of I buy one more unit of I, how much happy I get. Marginal benefit of having one more unit. Okay? And you learn the optimal marginal benefit should be equal to marginal cost. Right? And marginal cost is what? This is the money you pay for that. Right? And this must be, the lambda must be how much utility is it for $1. Right? So that's why lambda, if you learn intermediate micro, they will call this as a marginal utility of wealth. Right? Is give you $1, how much utility you gain. Okay, this marginal benefit, this marginal cost. Okay, this is undergraduate stuff, but we interpret in this way. So, or if you learn calculus, there's an M.Phil theorem, lambda, right? Because you total differentiate this with respect to y, du dy is lambda, right? This M.Phil theorem tells us, right? Is how much I pay at the optimum point. If I pay the consumer one more unit of income, increase y by 1, okay? The lambda, which is also part of the solution if you solve this equation, system, is how much utility gain, okay? So that's exactly same as what we said, okay? So this system, you should be able to explain, okay? I hope by showing you how to do this, you should be able to, when you write your model or when you try to read other people's model, you should know how to interpret because you're not just writing these equations. Of course, this equation is to write, right, from the math class, but you to explain what do they mean. You can explain why this whole, you can tell because monotone assumption, right? And this equation, how does it give us this internal external exchange rate? Because this holds for every single good. So you pick up this and pick up the other equation, you divide both sides, then you get what we want, right? Because you get two equations of those, you divide, okay? Or you can write in this way, right? This is how you can interpret this as marginal wealth, okay? Or you take this down, this up, this is our FOC, right? So that is the marginal cost equal to marginal benefit, right? Or the marginal utility of money. Right? I give you money or give you good, the same thing. Right? Although, is that clear what we're doing? Is that okay? Because I assume there's some minor knowledge of undergraduate microeconomics. But if you think I'm doing too fast, I can explain a little bit in more detail. But otherwise, I would just being slow, being quick here. Or interpret, I interpret this one. Okay, intuition. Okay. I think you can read that if you have problem, but I guess that would be okay. Or you have some question about that. Okay, or maybe I explain a little bit. Okay. In this case, if I give you $1, okay, your utility is lambda, okay, which is the right-hand side, this one. Okay. But what about this guy? If I give you one more dollar, how much unit of I you can buy? 1 over pi. 1 over pi is the unit of I you can buy with $1. How much utility you can get? Delta du dxi, right? And times unit you get is how much $1 you can buy for good I and make you happy. Okay? So same for the J. Okay, that's why it's du dj, and du dj is actually come from M.Phil theorem if you learn calculus. Okay, but I said we are not requiring you to know the M.Phil theorem. Of course, it'd be good to know it, but if not, then it doesn't really matter, right? Hopefully you know M.Phil theorem, but that would be something simple. Okay. So if you corner solution, okay. Actually, this will be the thing, but we are not required, but just put it there, is why you have corner solution is the marginal utility, which is the marginal benefit, is less than the marginal cost, right? So that's why you consume zero quantity on those, okay? But of course, this is from economics, right? The real proof rely on conductor condition, which means you're optimizing based on allowing zeros and inequalities, but that is beyond the scope of our class. If you ever want to learn that, then you have to pick up some math textbook, because we have said there we are only requiring math up to the basic calculus. Okay? Conductor is slightly a little bit more difficult than that. But anyway, I hope that helps. But I don't think you ever need it. Actually, I never in my research ever care about this corner solution at all. But probably some of you may need it. Let's put it here. Okay. And the next thing, there's something that you might need to worry, but not in this basic model, is it your solution, the FOC, turn out to be optimal? Okay. If your model is very standard, you don't need to worry, because if you assume standard assumption, everything will be, if I have done it, then you know it's unique or the solution is optimal. But sometimes if you write your own model, you definitely need to worry about SOCs. Okay? And especially when we talk about game theory, later your game theory solving Nash equilibrium, you need to worry about those. Okay? Instead of optimization problem, usually you don't have to worry. But when you actually solve a Nash equilibrium, that kind of stuff, you need to worry about your solution, whether it's optimal, especially a multiple equilibrium, right? There may be local minimum or local maximum. Have to be very careful. But for our case, you don't need to worry about it, because if your U is continuous, concave, and differentiable, then it must be optimal, because this is the way that being construct. I'm not going to show the proof. The proof is not hard if you read the textbook, but for the time, we just skip. Okay. Now, what we established is there exists a unique solution to this problem, which is not difficult to see, because you have a budget line and you keep drawing indifference curve, which is concave to the center, to the origin, and there must only exist one point that optimize. Okay. And because the problem is given by your income Y and price P, right? And there's only solution, so that's why the solution to this problem we call the Marshallian demand or demand function in general. Why Marshallian? Because Marcel, right? Alfred Marcel solved this problem first. Okay, and it is based on the price and income, and later you will learn the Hicksian using other shape. Okay, because in this model is maximized based on budget constraint. Okay, later you have other constraint, but this is the one that we talk about Marshallian demand, and I think this is the most common one. Okay. Now we deliver that. So the next thing is look at, as I said, we want to look at property. Okay. And probably some of you ask why we care about property, because we run regression, right? Because very often we estimate demand, we run regression. And running regression, you want to know what the property is, because that helps you to do identification. Want to check with the robustness, so on and so forth, or help you estimate. There's a reason why you need to learn some property of this. The first one is very simple. It's called the homogeneous degree zero, which means that if you multiply double your income and double your prices, everything will be the same. There's no scale effect here. Okay. It's very simple because it's come directly from the budget constraint, right? Your budget constraint is P dot X less than Y. If you double prices, double Y, the same constraint. Okay. Now this is very simple. Okay. Now the next thing is what does that mean in regression? It means that it doesn't really matter what currency you're measuring for your demand function, right? For example, right? Or you do any transformation to your price, doesn't really matter anyway, right? But if you do log transformation, it's an issue here. Okay, you can't really take a log, right? But you do any linear transformation, it's still fine. Now the other property, okay? You may want to say in our model based on P and Y, right? Where naturally you ask, what happens if price of one good changes? What has happened to its own demand? When price of good one changes, how it affects good two, good three demand? Or if Y changes, what happened to the demand of good one or good two, good three? Okay. Unfortunately, because the way we write the preference so general, there's no solution to that. Everything is possible. Okay. So that's why economists are very smart, right? Because they think everything is happening. So they will just give names, right? If you're good, your demand goes up with your income, they call normal good, right? If you're good, your demand goes down with your income, they call inferior good, right? Because we don't know beforehand what is good or is bad, right? So that would be the thing. Although we said there's a lot of freedom, but we do know that from economics, there's some good, there's a normal, there's some good inferior. Okay, so that is not too much trouble for us. But of course, when we run regression, it will help us to identification. Right? If you run, you estimate your demand. Okay, turn out to be there's some weird shape, then you have to be worried about it, right? Because the good is supposed to be normal good, but your sign running the income is negative, then you may run out some trouble, right? The second is on price of the price, right? And economists spend huge amount of time in the past try to prove demand is downward sloping. Okay, which means that if the price of good one goes up, the quantity demand for good one should go down. Okay, they spend a lot of time, and actually a lot of empirical work try to prove it. Okay, because in theory, this may not be true. Okay, things getting more expensive, you want to buy more, might be. Why? Go to Canton Road, 廣東道, Guangdong Dao. Okay, look at the luxury bag store, right? When they put up $1,000, probably you don't want to buy. 10,000 may want to buy. Okay, for some of the lady, that may be the case. All right, so that happens, right? Or or for some men, I put a rice wine here, okay? I said $100, you may not want to drink. I said $1,000, you may want to drink. I said $10,000, you want to drink a lot, right? So it can be your demand actually, right? Can be, increasing in your price sometimes, right? Because for marketing people, they know it's psychology. There's some psychology here, right? There's something price will signal you something as well, right? So that can be, okay. But economics will tell you a different story. It's the income effect, which we'll talk about later, right? They will talk about this lucky equation. That will be very important, okay? And what are the prices of the product that we call complement substitute, right? If the price of my good goes down, okay? If the other good, the demand goes up, then they're complement. Otherwise, they got substitute, okay? Because they have to consume together, right? It's complement, otherwise they got substitute. But we will talk about this a little bit later, okay? But I would like to illustrate this point because this is the thing that I would like you to know how to do it. I think the red one is the most important in this lecture, or it's the thing that I would like you to know how to do. This is asked in the assignment and exam. Is I give you the explicit problem, then I want you to solve it. Okay, because this class is not math class. I don't need you to prove things, but I need you to know how to solve this problem. Okay, so let's go slowly because I want to make sure that you're okay with that. So we have a utility function, right? This is a Cobb-Douglas style, right? It's x1, x2, and then the same index, okay? And you can see by construction, x1, x2 are symmetric, okay? Two goods. And this is the budget constraint, right? And why this would hold by equality, because monotone, right? By Wawa's law, the constraint would hold. So that's why Lagrangian would work, okay? So, and then we will do the same thing with differentiate with respect to x1, x2, and lambda. Give you three equations, okay? And with three unknowns, which is x1, x2, and lambda. In principle, you can solve it by hand because this is a simple system. Of course, you can do Mathematica if you want, okay? But even without solving, okay, you can start from economics, okay? Economics will tell you, you take these two equations and divide them, there's no lambda left, right? When there's no lambda left, then turn out to be, you look at the MRS, right? Turn out to be x2 over x1, which you can do it by yourself, is equal to the price ratio, okay? Or strangely, this is the amount you spend on good one, same as the amount spent on good two, okay? Because they're symmetric, you will not be surprised. They spend the same amount on the two good, okay? And because of they have to use up the whole budget, that means that you would spend half of your money on good one, half of your money on good two, right? So that is a quantity of good and good two. Okay, so this is how we solve it. Okay, so that is something I asked you, probably I asked you in your assignment or your exam as well, is to make use of more than one good, or the goods are asymmetric or a different type of function. You should know how to solve it. And why I need you to do it, because this is how, if you ever write a model, this is, you need how to solve it. All right? Of course, you have to justify why the budget constraint would hold, why this FOC would mean, what does it tell you, right? What happened with P1 changes, what happened if Y changes. You can tell all those things, right? Without a problem. Okay? Is that clear? All right? If so, then let me talk quickly. I mean, probably I would just skip because I don't think it's important. I would want to talk about something important. Is this definition is not very important, but it's very often mentioned. It's not important by itself, but this is the important concept to know. Okay, this important concept is called elasticity substitution. Okay, And the way defined is the following. Okay, when you see elasticity, usually involve log. Okay, so log in terms of calculus is percentage change. Okay, so here it means that, okay, the definition is change how the ratio of your good I over good J, okay, your ratio, percentage change, in response to change in marginal substitution. Okay, it is very weird definition. Okay, that's why the definition is called substitution. Is how substitution changes. If in your mind you think I suddenly become more important than J. Okay, for 1% more. How your consumption actually changes. Right? That is a definition. Okay. Let me repeat. If you think that good I, you need 1 more percent of good I to, good J to change for I, right? Because MRSI is what? How many J needed to compensate your 1 unit of good I, right? So if this ratio changed by 1%, okay, that is the log mean, right? How your consumption ratio changes, okay, relative consumption changes, how percentage changes, okay? And luckily, okay, in terms of the market, MRS is equal to price ratio. Okay, so that means that how price changes change to your consumption changes. Okay, that is what it means. Okay, and you can write in this way. Okay, why this is important? Okay, and because to run regression, right? You take log regression. It's easy to estimate. You have two goods, the price ratio, right? This observable in regression. You can run a log regression. You figure out this epsilon, easy estimate, right? Why actually? I mean, whenever you read textbook, you often see elasticity. You wonder why, right? Why would I care elasticity, right? Because run regression, they are easily estimate, right? You can't actually estimate a lot of stuff because elasticity is a local thing, right? In the real world, you want to observe some local thing. So that's why elasticity is often used here, right? Because that's the only thing you can observe. And you can actually run a regression, right? Because remember, the demand you can estimate, price you can see, the thing can see, you can estimate this. Of course, there's some issue about econometrics, but in principle, if things are all right, you can estimate it, right? Of course, econometric class will tell you the price. There's some issue about the price equilibrium. But imagine the case you are the firm, you control the price, right? Then you can estimate those, right? Of course, the price is observed somewhere else, then there's some issue there. But if you're firm, you can change P, right? That's no problem, right? You can estimate this. Now, why we care about this? Because of this very famous utility function. Okay, this utility function is not Cobb-Douglas. Cobb-Douglas product, right? This is sum. Okay, although it looks very something weird, right? It's additive, right? Because it just say how much good I will spend raised to the power delta, and good 2 and good 3, right? And turn out to be this interesting thing, okay? Has some substitution, right? It seems like they're separate, right? By adding things, right? You imagine that the goods are unrelated. It's like they're unrelated thing, right? But they're linked by the budget, right? How much you can spend on good one will affect you how much you can spend on good two, right? So in terms of utility, it's additive, right? But you still have substitution there, right? So turn out to be this. Okay, this delta is actually related to this. The substitution is always 1 over 1 minus lambda. And actually, this utility function incorporates the 3 common cases. Okay, at a special case. Okay, and that's why you will see many papers, okay, currently in the trade, in the macro, they all use this. Okay, they either use the CES or a nested CES. Okay, you can consider supply chain. It's like this. It's like all the input. Your firm combine many input, right, and produce based on Cobb-Douglas production, and consumer use Cobb-Douglas CES to combine different good from different firm for the consumption. So it's a nested CES. Okay, so it's a very but this is very commonly used because easy to estimate, right? Because as I told you, just estimate this guy, right? And this guy can be estimated easily. So that's why they're so commonly used either in theory or empirical. And in terms of theory, this function is easy to do calculus. Okay, although there's no closed form solution in many cases, but the FOC is easy to characterize. Okay, so that's why I give 3 special cases, and I recommend you when you do write a model, you try with the 3 cases. If everything goes through, you can actually hope to generalize to CES. You never start with CES, as I said. Okay, start with the Cobb-Douglas. Start with the perfect summity or perfect complement. If everything all right, go to the CES. Okay, and then there's a high hope that you will hold. Okay, and usually I will leave this will be an assignment. Okay, probably I will do the same. I ask you to do CES, maybe 2 good or 3 good. You derive the optimal consumer problem for me. Then you know how to do the problem. Okay, maybe I give. Okay, that would be the standard thing I would usually ask. Okay, or maybe in exam or assignment, I don't know. I haven't figured out what I'm doing to this year. Okay, I think I will skip some of the slide. Okay, in the interest of time. So before the break, I'll talk about the last thing item. It's called the indirect utility function, which is actually more common when you write a model. Okay, sometimes it's more common. You assume that utility not depend on your consumption bundle. It's depend on price and income. Why? Because it's a number that can easily observe. You observe the consumer, how much he has, and what the price of the product, then it's easy, right? Because usually you can't observe what are the quantity of the good they consume, right? By looking at the V, that is easy. Okay, what is V? V is this the utility, right? Subject to budget constraint, the maximum problem, right? So that's the optimal utility, right? And based on the optimization problem. Okay, and of course you can basically plug in the solution here is called the indirect utility function. Okay, and as I said, why you care about this when you run regression, this is what you can observe, right? You can't really observe each one's consumption, but you can observe the V. So in application, actually this is more useful than the Marshallian utility. The indirect utility you can start, okay? But why we learn this class? If we can start with the V, why we learn all the way from U? Why? Because U, the restriction on U will give you the idea on V, right? You make assumption on U, then we can know what assumption on V there, right? Because making assumption on V, that would be crazy. How can we know what the shape of V? But making assumption on U, is we can do it, we can think. I mean, it's hard for us, I don't know you, but it's hard for me to think how P changes with V, how Y changes with V is very difficult to think, right? But making assumption on U, I can do it. And I can translate it to the assumption on V. Okay, let me give an example. Before we do that, there's some property that is not surprising. The first one is your V will be non-increasing in Y, right? More income actually will not make you worse off, right? And higher the price cannot make you happier, right? Of course, if you look at CCTV, sometimes they said people are welcoming the increase in price, but it's not violate, right? It still can be equal, right? It's not violate. And here we have homogeneous degree in zero price and income, right? So you double the price and income and then the same. Okay, that's very important, right? Because when you estimate the econometric model, that have to satisfy, right? And the final one is nothing new here, is the Roy identity. Is suppose you come up with the V, you take the differentiation, you get the X. So that is very important result because you only observe P and Y. In the real world, you don't observe X. But once you estimate the V, you can back out the X. You can estimate demand through this way. So that is very important result. That's why they call Roy identity, because that is invented by Roy. I forgot his first name, but this guy invented, and that is very important for estimation, right? Because you imagine you do marketing, right? You observe the P, observe the Y, you know the consumer how much he has, right? Look at the credit card spending, right? But you can back out this, okay? If you're willing to assume certain assumption of V, right? So I'm not going to prove anything. How to prove Roy identity basically come from M.Phil theorem, but I'm not going to do that, okay? Instead, I want to talk about this was the last slide before the break, is how to derive that, okay? If we are going to assume your demand is coplocalous, special case square root, okay? How we can get the V function, right? And remember, we derive that if the symmetric case, consumer will spend, you split the budget on two goods, okay, equally, right? Half the money spent on good one, half the money spent on good two, okay? And that means this is the function here. You plug in the optimal solution, right? This to this one, and this is the one. This is your indirect function, right? And once you have this, you can do many things, right? If you're willing to assume utility this way, right? Once you pick up this, and you can back out everything. All right. So that's why we need to learn indirect function, because when you do empirics, that's just where you start. And very often, we may even write the model in this way, right? Because we only in macro, right? You want to estimate the social welfare function, right? This is you have the Y and the P, right? You can actually evaluate how people, right? So I hope that also explain why, right? Y is the GDP, right? P is the CPI, right? Actually, if you assume people are coplocalous, you can come up with a happiness index, right? According to this, will be the GDP over 2 over the square root of CPI, right? So, I mean, of course, it's very crude, but you can imagine that actually there's something here goes on, okay? If you are doing happiness study, okay? I think I skipped many slides, but those slides are not very important. Maybe I should black it out in the future years. But I think I covered the thing that is most important, crucial. I think I still use it, and you may still find it useful. And let's a break of 15 minutes, and then we'll talk about the cost minimization problem, which will be much faster because very similar anyway. So let's a break of 15 minutes. Let's resume at 1:40. 15 minutes. I'll open the U reply so that if you can tell me it's too fast or too slow, or you don't have to write anything. In case you want to leave any comment, then you're welcome to do it. But otherwise, please take a rest and come back at 1:40. I'll be around to answer any question that you have.
声音都改了。应该是，上几人跟我说应该我没有，应该 OK， 那个拉。 So, no one doing anything, so I assume this is okay. So, no response is good response. No news is good news. I assume this is a good one. But if in any case, you can just keep it there so that you can do it after our second break. In case you want to have some comment, suggestion, whether it's too fast or too slow, you can let me know. I can adjust. Okay. Of course, some of you said I'm too slow, implying I'm too slow, especially the people in the math major or people who learned before. Or some people think it's too fast if you haven't learned. What you learn is undergraduate introductory micro, then you will find it very fast. I just draw the middle line so that everyone can benefit from this class, especially for those who has to have come to this class because of requirement. So hopefully I don't lose you too much. And then I focus on economic intuition so that even though you find it very easy, you still find this class a little bit useful because it's important how to interpret that, right? Because, for example, in this one, all right, you see how y and p related to the v, right? Y the square root, where it comes from, right? Again, you can imagine that if you change this index, how does it imply to the V function, can be very useful. Intuition to give you, okay? Now, after the optimization problem of maximizing, we can have a dual problem, which is minimizing, which the same, okay? In general, they can be different, okay? But in this particular case, they're the same thing. Whether you are maximizing utility subject to budget constraint, or you're minimizing expenditure to achieve the minimum utility level, they're the same thing. You can imagine the thing is a line, fix a line, you figure out the indifference curve, highest point, or you fix the indifference curve, find the budget line that achieve the minimum budget, right? That would be the same thing, okay? In this particular context. But in other cases, it need not be the same thing, okay? So if you learn linear programming, you learn the same, okay? So the dual will be the consumer try to minimize his budget to spend, subject to make sure that he's as happy at the minimum level U bar. Okay, so that would be the problem, right? It's not very natural, right? I mean, if you ever think about this, you never thought this is related to how human thinks, right? Because you always maximize the utility, right? It's not, budget is not a concern, right? But this, you can imagine this satisfy firms, right? Later you will see the firm will be minimize the production cost subject to production target, right? This is way, and when people see this, right, they would actually see the firm and the consumer will be very similar, right? Because actually they're similar in that sense, right? But anyway, let's see this because we will do it in the firm, but we see it here, we see the technique, then everything will be translated, okay? And the first thing is, if the price are positive, okay, and preference are monotone, and the consumer is binding, okay, then we can use Lagrangian. You don't need to conduct her. The reason why it must be binding, because it's costly, right? You don't want to have a lax in the constraint, right? Because if constraint, you have utility higher than the baseline, the benchmark, what you want to achieve, then you can consume less and save money, right? So that is the proof here, right? The idea is if you have some utility higher than what required, you can spend less, right? Still satisfy the constraint. Okay, so that is a proof. Okay. And it turns out, which is not surprising, the solution should give the same thing. The marginal rate of substitution should be same as price ratio, right? I mean, because this is the same problem, but different perspective. You shouldn't expect different FOC, right? And some of you may ask why you want to do it this way or the other way around. It's because, as linear programming tells you, sometimes this is easier to solve, sometimes the other way is easier to solve. But in this particular case, there's no difference, okay? So that's why it doesn't really matter anyway. But sometimes it is much easier in this way. Okay. And the proof will be the following: why this holds, okay? And you will see when you write the Lagrangian, this is the solution, right? The F was like this. This is exactly same as your consumer problem of profit utility maximization. Okay. Only difference is this part, right? In this, before we have budget constraint. Okay. Now is the utility constraint satisfied. Okay. But otherwise the same. Right. So that's why the FOC rely on this one. Continue to hold. Okay. And what we have is turned out to be a very interesting thing is another demand function, right? Because this demand function actually depends on not price and income, but price and utility level, right? So this is what we call the Hicksian demand or compensated demand. Okay. And okay, so this is given to you, I minimize this. And as we said, these two problems are the same. So there must be some connection between the Hicksian demand and the Marshallian demand, right? Because they are solving the same problem from different two perspectives. So the first order of business is how these two demand functions are related. How can we connect the Hicksian demand and the Marshallian demand? And here comes the most important thing in this chapter is the Slotky equation that connect the two. Okay, but we'll do it when we save it, when we talk about this. But before we talk about the demand function, okay? And do note that the Hicksian demand is a conceptual device. The reason is we never know our U bar. In econometrics, you observe, no one observe U bar, right? What is the utility level you want to achieve? It's very difficult to do, but it's a very useful conceptual device. Why is it important? The first thing is, not surprisingly, if you double the prices, nothing changes, because double the prices don't change the exchange rate outside, because price ratio remain the same. It's still P1 or P2 for the good one or good two, right? The exchange rate outside is the same, okay? And for you, it's still the marginal substitution, the same. So the solution remains the same. Is that clear? Okay, of course, your total budget increase, okay? But your consumption, the ratio, the demand curve remain the same. Second, which is very important, okay? Turn out to be this Hicksian demand is downward sloping always, which is something economists try to work out because we think that things become more expensive, right? You should spend less, right? You should buy less when things are more expensive. Okay, this is the Hicksian demand. I actually have that. Okay, but not the standard Marshallian demand. Okay, so our intuition is right only when we look at the right problem. Okay, so if you look at the wrong problem, you get a wrong conclusion. Okay, but at least we know this is right. Okay, not going to prove it. If we rely on some proof, I think you can read that if you want to, but I don't think you will need them. Rather, I want to show you this problem again, which you will be solving it for your assignment, right? Or similar problem. It's your Cobb-Douglas utility function. First, we want to derive this expenditure minimization problem. Okay. Now, I want to minimize expenditure subject to the constraint. And why Lagrangian works? Again, because utility is monotone, price is positive, so it's a linear equality that must be holding. So when you differentiate to x1, x2, and lambda, which is the Lagrangian idea, right? This gives you B system of B equations, right? And again, if you divide the first over the second one, give the same thing as the utility maximization problem. And that means that they still spend the same amount, splitting half the budget on both, okay? But we don't care about budget. Rather, we want to look at what is the Hicksian demand, okay? That is, okay? We figure out solving this system, okay? Turn out to be, actually you should check at your home why this is correct, okay? Your demand will be ratio of the prices, take a square root times the utility. It's linear in your utility targets, okay? And related to price ratio, okay? So you can easily see that if P1 goes up, X1 goes down, okay? And P2 goes up, X1 goes up, right? And U bar goes up by 1 and X1 goes up by 1. So that would be something that will be interesting, right? Because we assume Douglas, this is the form hexane demand you have. And I'm going to skip this because I don't think that is important. And the next important thing is called the expenditure function, which tell you how much a consumer would optimally spend given the price and utility target. Okay. And this solution can be coming from you just plug in the hexane demand times the price to get this expenditure function. Okay. And again, you ask why we care about that. You never observe U bar anyway, right? You never seen U bar anyway. So that would be an issue about econometrics, right? Because you never seen this. So how can we do about things, right? That's an issue. But that being said, you observe the expenditure, you observe the prices. If you have this function, you can back out U. Let me repeat the statement. The expenditure depends on price and utility, right? That's you observe expenditure, how consumer consume. Observe prices. What you can do is back out the U, which is not possible if you don't have this function. If this function, right, you can back out the U. Let me see the example, then you will see what I'm saying. Okay. Now, before we do that, let's see the property first. There's some property, but we shouldn't surprise you. The first one is if you double the prices, you double your expenditure, right? Because your consumption bundle will be the same, right? But things getting double more expensive, right? And price goes up, expenditure will not go down. Not surprising. Okay. Now the more interesting thing would be 3 and 4. Okay. 3 would be saying that little bit crazy. Probably I'll explain a little bit. Is you have 2 different prices, okay, and under the same utility, okay, and the linear combination is less than that. I'll explain a little bit later. But this is what do you mean by concave in prices, okay? But I'll explain later. But most important part is this surplus llama expenditure differential the price gives you the hexane demand. Okay. So one thing is, suppose you have some expenditure function, which you look at the expenditure, how people spend, look at the price changes, you have the how much the hexane demand they have, right? That means that you have how much you look at the econometrics, look at the policy changes of price. Okay. Suppose look at utility company. Suppose the price of electricity goes up, right? And you look at how people consumption changes, you can back out how much they spend. So how many units they spend. Okay. If you willing to make some assumption there. So that is the surplus llama is very useful, right? Because you can back out the demand by looking at prices and their consumption. Right. So that is very useful, right? Because otherwise you cannot really look at those, right? Look at Marshallian, you have to rely on the income, right? You are never unless you have micro data, you cannot observe how much they make. But you can observe how much they spend, say credit card data, or how much they spend on the good. You can look at that. All right. So that would be easier to see. Okay. Okay, anyway, let's see the why is this a concave. Okay, I'll give the intuition that we carry a lot. Okay. So consider we're too good. Well, but we only change price of one good. Okay. Now, why the expenditure is concave? We're going to try to explain this blue line. Concave means this shape. Okay. And consider the case, this is P, right? And I would draw this P dot exceed PU, okay? And given this P is here, okay? And this linear and this one, right? Because linear line, right? And why the case? Because you increase your price, right? Then you will just go on this line, okay? But if I change the P1, right? And actually your expenditure will be less than this one. The reason why is being that you will do substitution. If I increase the price of good one, you can buy other good. The worst case, you keep the same bundle, right? You keep the same bundle, it'll be linear, right? The red one will be saying that you are not optimizing, okay? You still consume the same bundle, that will be linear. Is that clear? So suppose the optimal point is the black one, okay? And price increase or decrease. If you keep the same bundle, your expenditure will be the red one. Is that clear? It's linear, right? Because other price hold unchanged. But you are smart. You are not going to keep the same bundle, right? You can try substitute. You can buy cheaper one, right? So that means that it must be lower, which is the blue one. So that's why it's concave. Okay. And what does that mean? If we mean want the regression of expenditure over the price, if the square term must be what? Negative, right? Right? What concave mean, right? If you regress expenditure over price and price square, negative. Right? So that actually tells us something, right? When you look at this, why we care about concavity and convexity. One regression, you see it, right? Or then it makes sense. You say, suppose I run log the price, you will also make sense because it's concave. It's a concave, right? So you should know why sometimes you can take log, you can take things, it's also fine, right? If it's not concave, it's a convex, you make a convex transformation, maybe easier, right? So I hope that tells you why we want to learn all this stuff, even though none of you are, but most of you are not going to do theory. Okay. The next one is the Sharpest lemma. There's nothing new, but just M.Phil theorem. As I said, why we care about this is when you have expenditure data with price data, if you're willing to assume some functional form, you can derive the demand, right? You can see how people consumption changes, okay? Even though you don't observe it, right? As I said, suppose you observe what is the revenue of a utility company, right? And look at the price they charge the people, you're willing to fit in the data, then you can estimate the demand, how much people have used in terms of electricity, right? If you don't observe quantity, right? Or you can say, I observe how much people spend on food, okay? And look at the prices of food. I can estimate how many units people consume, right? That's how people said, right? But look at prices, okay? I hope that tells you that estimate demand, okay, can be done without looking at actual quantity. Even look at prices and total expenditure, you can back out a lot of stuff if you're willing to assume the utility function, right? Because that require you to have some assumption on that. Okay, so let's see in practice how you do it, right? You have this U, right? And then it's a price, right? This is what we figure out in the last example. You just plug that in, that gives you the exponential function, right? Of course, you can run a regression, right? Take a log on both sides and run it, right? It's not something very terribly difficult, right? So if you're willing to make calculus assumption, then that can be, right? If you don't want to square root, you get a more general form. This will get a more general form, but you can estimate those. Okay, there's nothing very deep there. There's some parameter there, right? So here comes from the comes to the very probably last part before we do consumer surplus, is how we connect the two problems. Okay, how we connect the UMP and the EMP, right? And how the Hicksian demand and the Marshallian demand are related. It's called the what we call later you see the Hicksian, so it's lucky equation. Okay, but we can explain in terms of graph. Okay, so the first thing is they're related in the following way, right? This is the Hicksian demand, right? Price and utility. This is the Marshallian demand, the price, but you replace the income by expenditure. Okay, or you replace this Hicksian demand by indirect function. They're the same. So the four are consistent. So if you get one, you get the other four. Okay, you should be able to get, if you estimate one, the other three will come out. Okay, of course, there are a lot of economic problem to link the four. Okay, and if you're able to solve them, you can publish a economic car, because there's a lot of many issues how to aggregate this in terms of real data. Although I said a lot of things seem so easy, but if you have the data, it's not that easy. There's a lot of issue here. Okay? But probably the main key thing is this one of this class is you care is the price effect. Okay, means that two things, substitution and income effect, and why this decomposition is useful, and because it often appears in empirical result when they study. Okay, when you say when price changes lead to change in demand, okay, they will often tell you you decompose it into substitution and income effect. Okay, what are they? If you learn intermediate micro, then you know very well. Okay, the first substitution effect means that holding, if the price of one good changes, okay, suppose you're given no budget constraint at all, keeping the utility the same, how much you would change. Okay, that is the Hicksian demand idea, right? Keeping your utility the same, change in price, how you would swap. Okay, you don't care about money. Okay, say price good one goes up. Okay, in order to make your same utility, how you change. Okay, substitution actually look at the Hicksian demand. Okay, and the income effect is because of the price changes. Okay, then you want to make sure that the income will change accordingly, because even though you use the same bundle, right? You would need to get more money, or you're taking some money out of it. Okay, and that was second part. Okay, maybe a little bit not easy to explain. Okay, but let's look at the graph first. Okay, so look at this point. I should this is point number A. Okay, point number A is the optimal point. Okay, the budget is inner budget is this one. Okay, this is optimal solution. Okay, suppose goods one become cheaper. Okay, it means that you can buy more, which is budget constraint from here to here. Only P1 changes, P2 same. Okay, so the total effect, if you look at the Marshallian demand, is from here to here. That's a Marshallian effect. Okay, this is what you observe in the real world. The thing is, I want to know how it being decomposed. There's two effects there. One is called substitution, one is called income effect. Substitution effect says, okay, now the changes is the price increase, not just change two things. One is the price goes up. For you, is the price ratio changes. Remember the FOC. FOC is MRS equal to the price ratio. Optimal point, right? It's internal exchange rate and external. Okay, forget about the budget. Just change the price ratio changes, right? And your internal amount will change accordingly. Make you the same indifference curve. You would consume this bundle, right? We don't talk about the budget, but this Hicksian demand will tell you you're consuming here, right? So this part is something is fair. Because of the price ratio changes, you want to keep your same utility. that is the new consumption. Okay, so that is a Hicksian effect. Okay, and the next part is income effect. Why? Because good one is getting cheaper, right? Even though you consume the same as before, you have extra money left, right? This extra money you can use to buy stuff. Okay, so you move up. Okay, so that's why you always in empirics, okay, you always decompose in two parts. You want to understand what's going on, right? Because of income effect will be positive for normal good, right? If inferior good, you'll be negative, right? So you really want to decompose in two parts, and then you see what's going on. And decomposition is the very important thing when you do theory, right? Because you have a humongous object there, okay? And then you try to explain certain things, okay? And you want to decompose it in multiple parts, right? In order to see what happened, right? Same when you do experiment, you also want to decomposition, right? Macro or marketing or a lot of stuff, you want to do decomposition, right? The total effect is here. Okay, you want to explain by looking at different parts. Okay, and first thing to do is let me repeat it because this is so important. Let me repeat this argument again. Okay, because if you haven't learned intermediate micro, this is something crazy. Okay, the question is, initially, the consumer choose this guy. Okay, and now good one become cheaper. What you observe is this point. It jumped from here to here. Okay, and this is effect we know. Okay, but we want to decompose in two parts. Okay, the first part is because price changes, there are two effects. First is because relative trade-off changes. Remember, our consumer problem is marginal or substitution equal to price ratio. Okay, that is nothing with the budget, right? So when price changes, you just already change yourself, right? So that's the FOC tells you to change. And that's Hicksian demand, right? You keep yourself on the same utility function. That's a Hicksian effect, right? If you look at the Hicksian demand, that's what you get. Suppose you have Hicksian demand, right? The first part. And the second part with the income effect, which says because of good one become less expensive, even though you spend the same bundle, buy the same bundle, you have more money, right? But now, of course, you would do this anyway. So this is the part that shift up, right? You have more budget, right? So basically you spend more on both, right? Now you're able to spend more, okay? And if it's normal good, then it goes up. If inferior good, it will go down, okay? So you want to decompose it in two parts. Using some assumption, you can back it out because, of course, you never observe this guy, right? This is hypothetical. But when you make assumption on utility, you're able to decompose it in two parts, right? Then you can estimate, you can tell people, right, how people changes their behavior, right? Suppose there's a war, oil price goes up, you can see how people changes. Is it going to substitute, going to income, which effect dominates? And there's nothing I can tell you with which part dominate, depend on empirical result, right? And you can see they can go different direction, right? So things can be very different. I cannot tell, but this decomposition is very useful when you talk about how consumer changes. But you can see this tells you that how in theory you do decomposition, right? Because you can imagine that say you do supply chain, right? If there's a raw material getting more expensive, right? You transmit it to the wholesaler, transmit to consumer prices, right? You can always decompose it in this way, right? How things changes according along the supply chain, right? Or there's a distribution channel, right? How things propagate from one to the other, right? You can look at the total thing at the end, but you can decompose it along the chain, which is also very useful. I mean, maybe not many one of you would do this, but the idea of decomposition is very important because you can hypothetically add something and try to study something. Why is important? Because from theory, we know how it looks like. In theory, we know how it looks like, right? Then we can have some, we know more a little bit. Okay. And if you cannot econometrics, right? Because you can back out some underlying parameter and do better prediction, right? So these are the reason that we want to study that. And the math actually is not complicated because I'm not going to go to detail, but that's basically the Hicksian demand and the Marshallian demand are written this way. You take total differentiation and move it to the right, then you're done. Because this is the Marshallian demand, this is the Hicksian demand, this is income, this substitution effect, this is income effect. Okay, but I'm not going to talk about this because this is not a math class, right? So I don't want to bother you with the math, but this is the equation. I mean, in case you want to know, okay? Because I don't want to spend too much time on the math. Okay, if you really want me to do it, I can do it. And because it's not the crucial one, right? Because I don't think you ever, for me actually, I never use Slucky equation, right? Except for you look at the empirics where income something that would be what I do. I mean, I'm not going to derive that, right? So as long as I understand the logic, that will be okay, right? But I mean, the logic will be something like this, right? You would build the inequality, right? You differentiate both sides, and you would get different effect. I hope that would be probably something that you can take it with you. That would be useful, right? But otherwise, this is rather standard thing. I'm not going to talk about those. Okay, but this technique would be useful, right? Because you would be looking at one coin, two sides, right? The same coin, two sides, take differentiation, right? And you can look at different effect, right? So I hope this is a standard technique. There's nothing unique to this consumer problem, right? So I want to very briefly talk about welfare. Okay, welfare. And so the idea of welfare is why we care welfare. And if you learn undergraduate, you will see we care about consumer surplus, right? And consumer surplus is simply the area under the Marshallian demand, right? If you still recall, we do consumer surplus, it's like this. What do you mean by consumer surplus? This is demand, if you still recall, this is the price, this is quantity, or maybe Q, that is undergrad, right? And you have a demand curve, right? And then we said, oh, this is the market price, P star, right? And what is the consumer welfare or consumer surplus will be the green, right? That is something we know, right? And we want to justify this after the break. Why this accurate measure? This is a good measure of consumer welfare. How this part with utility, right? Because why under the demand curve is representing welfare at all, right? How with the utility? So we give you the idea, and turn out that the consumer surplus is not exact measure of your utility, but rather depends on where you look at the problem. Okay, and this is the approximation of what it's supposed to be. So there's upper bound, lower bound, and consumer surplus in the middle. Okay, and we'll talk about it in detail why consumer surplus is a good measure. And before we do that, why probably some of you would wonder why we care about consumer surplus at all. First is consumer surplus is how antitrust being evaluated. If two firms get merged, consumer surplus will be the thing people care. Okay, at least in the US. Okay, when US, they'll care about consumer surplus. And the EU, they'll talk about consumer surplus and firm's profit together, total surplus. The reason being that firms are owned by people, so profit go to somewhere, so that will be go to consumer surplus as well. So there's a yield. And in China, I think they would do the antitrust is somewhat in the middle, somewhere in the consumer surplus, somewhere in the total surplus, somewhere some combination of those. Sometimes they say consumer surplus, sometimes total surplus, but anyway we do. Okay. And second, although we didn't mention in this class, is sometimes when people try to model firms' behavior, right? And the shortcut is not to model competition, or not to model consumer, not to model anything. Okay, not to model price and quantity. Okay, they just model the firm will maximize consumer surplus directly. Okay, don't model anything, just model consumers surplus. Okay, and different firm try to model, you put some function on the consumer surplus and just model it directly. So that's why we need to understand what's the foundation of the consumer surplus. Why? Because you want to make the right assumption, right? You want to make this consumer surplus is well grounded from the first principle, right? You don't want to make arbitrary function of consumer surplus, right? Consumer surplus should follow certain kind of behavior, right? At least when you make assumption, you know what you're making assumption of. Okay, does it make sense? Maybe with a break of 15 minutes and we continue back to welfare after break. Zoom at 2:45. Again, if you have any question or comment, and you don't want to ask directly, please you can leave your comment in the QR code in case you have any. Okay, let's see if you have any comment suggestion. I guess not. So no news, good news. Yeah. So far, someone joined but haven't filled in, so I assume everything's okay. So let me go back to this slides. Okay. So welfare. So the first one is a little bit slightly easier to see. Is we look at small changes in prices, say, okay, and that's often appear in empirical exercise, right? Suppose you have implement some marketing campaign or government policy, you change some prices, you look at how consumer changes, right? Where they're happy or not, right? You want to see how change in utility, right? This is DU, and D is a notation in calculus. It's just small changes. If you don't like, you can use the big delta, right? Just change, small change. A small change in price and small change in income, right? How does it change in people changing utility, right? This is what you want to measure, right? And then, of course, you want to see people happier or your consumers happier, right? And if you remember, you differentiate this, and this is total differentiation, right? And this part turned out to be from FOC is a lambda PI, right? And lambda is marginal utility money, right? You can take down, and for small changes, you can safely assume the lambda will be the same, right? But small changes, but big changes, lambda will be different, right? But that means that the change in utility is based on the price change times the change in quantity they consume, right? So look at the prices, look at the change in consumption, and measure the change in utility, right? That's very useful in policy world, right? Because you never observe how utility changes. You look at the prices, okay? Look at how people consume, and then look at how their welfare changes. That's the most easiest thing to measure, because here, why is easy? Because I don't need to even assume anything about utility. Make no assumption. As long as the change is small, I just look at the price times the change in quantity, and that's done. There's no assumption is needed, right? I don't need to assume utility Cobb Douglas, take a square root, whatever, right? as long as they satisfy certain property, which guarantee some nice solution there, monotone, so we call it concave or those kind of thing, continuity, right? Everything is well done and then done, right? So policy world, that's the most useful one, right? Or you can look at the marketing campaign, look at this, right? How they change the budget, right? Then done, right? Remember, this is how look at the budget, right? That's approximation of the indifference curve by budget constraint, right? Look at how people change. Of course, this is the useful in empirical world, but we want something more, right? Can we come up with a function that tell us how consumer welfare or how some consumer utility changes, okay? And the way to do is we start with the indirect utility function. The reason is because we observe prices and income, right? In many cases, right? As a government, because of our policy changes, right? So consider a case where initially the price is 0, the income is Y. And now I change in price to P1. Why you do that? You imagine Trump goes in, they impose tariff, or impose surplus, or price control, or tax, which very often in public economics, right? So you can see new price, okay? And income will be the same. So if know the function V, then we can calculate the indirect function, right? So the question would be, okay, is the consumer better off or worse off, right? How to quantify the changes, right? Because price is a vector, right? Many prices, so you change some prices, you increase something, you decrease something, right? So how does that work? Is it going to be better off or worse off? And there, in theory, at least there are 2 different ways to look at this problem, okay? To measure how people are better off and worse off, okay? And it depends on the benchmark looking at, okay? The first one, okay, is what we call the compensating variation. The definition is very weird, so I will be slow a little bit here. Is, remember, VP0Y is initially utility, okay? And what we want is, under the new price, how much income I can take away from that guy to make him the same before. Suppose the price drop, he has more money, right? So I take away the money that make him the same as before. That is the compensation variation, okay? Or the price goes up, I have to pay him, right? So that's one negative amount, right? So how much I pay him to accept the changes, that's why the compensating variation, to compensate, okay? To make him as same as before. Okay, so that would be the idea. The benchmark the past, not the future. Okay, look at the past and anchor the past. How much I need to compensate under the new scenario, make him as same as before. Okay, now you can see I anchor the past, I also anchor the future. This is our benchmark. And look at the past, how much money I need to give him to make him the same as now. Okay. The money I need to give him, he's happy to avoid this. Okay, he need to wait. Okay, so that is the 2 things that's equivalent, right? Because I do this, it's equivalent to the changes. So that's why they call equivalent variation. Okay, as you can see, right, there are 2 schools of thought, right? Whether you anchor the past or anchor the future. That's not surprising. This is not something you need to consumer surplus. Imagine advertising. Advertising, you do advertising, you change people's preference, right? How you measure that? How you measure the consumer's welfare changes? Measuring based on the new preference or old preference? Depend on benchmark, you have different result, right? So same idea here, right? Whether anchor the past and the future. Okay. And you can easily see that nonlinear CV and EV will be different, right? I mean, unless we're special case, they're the same. Otherwise, usually they're different. Okay. And the question is, which one you should use? Okay. Of course, depend on philosophy, which one to be used. But turn out to be, we'll try to prove if you have time, but otherwise we just argue. Consumer surplus is in between the two. Okay. So that's why we use consumer surplus. It's a compromise between the two. Okay. I'll argue later, but that would be the idea. That's why we use consumer surplus is we don't want to pick side. Okay. CS consumer surplus is in the middle of the two. We'll try to argue. In some cases, this is larger. In other cases, it's larger. Depending on the type of good. Later we will try to, if a time we will try to argue. Okay. And this is the money. The reason why this definition, this is how people think, right? But we can't measure utility directly. Okay. So how to operationalize this is look at expenditure, right? And as I said, compensating is look at new situation, new utility, how much you spend, you need to spend, minus old utility and the new price, right? How much I need to compensate you, right? Under the new price, okay? And equivalent, okay, will be looking at the old prices and change in utility, right? The difference is whether you look at new price, anchor, or old price. Okay, so these are the two definitions. And to derive them, you would just use the math. I'm not going to do the math because they are not difficult, but they are just too tedious. I mean, you have to be very careful checking this definition means this difference. I mean, everyone can do it. I'm pretty sure you're doing PhD, everyone can do it. But you have to be exceptionally careful to definition. Just play around definition. Okay? And I don't think there's any gain from going to the definition, play around with that. Okay? I'm not going to do this. But rather, I want to illustrate this in the graph to tell you what is EV and CV in terms of graph, then you have the better idea. Okay? I think this is the most important thing to stick in your head. Okay? So initially, again, this is the initial bundle. This one, initial one. And price changes give this guy, right? This is the Marshallian effect, right? If you still remember. If you go to this one, this is the substitution effect, this income effect. Okay, this is the old graph you have seen already before the break. So what's new here? Make some assumption. Price 2 is 1. Okay. And then this shift is a CV. Why? This is the amount I need to compensate by, right? Looking at the new prices. Remember CV before? Look at CV before. CV is different utility curve under new price. So under new price P1 is this new price is this low, right? This old utility, this new utility. And the CVY because the price is 1, right? The change, if you spend all your money here, spend on Y, right, will be the expenditure, right? So CV is measuring this go up. Is that clear? Is that clear? This is the CV. It's the measuring how much, right, to compensate. Okay. If you jump from here to here, how much money I need to pay you. Okay. Now look at the EV. EV is a little bit Not that difficult if you imagine, because that is saying that using the new old prices, right? And I look at this utility here, and how much I need to compensate. Is it easy? Right? I just, instead of bringing this line down, I bring this line up. Okay. And this is the we define as EV. Okay. So you can say both of them are actually valid, right? Depends on which one you think is the appropriate, right? Which one you think which price you think is the anchor point. Okay. It's a philosophical debate, which one is better. But either of them would work, right? And as I argue, CS concept actually is in between the two. Okay. But let's see if we have time to prove it. Okay. Just to go back here, this is CV and this is EV. In general, they're different, right? And probably end up the problem is which one to use. Okay. And I argue that CS will be the best compromise. So let me repeat. CV, right, in this case is looking at the old, looking at the new prices, how to shift up, right? Fix this utility curve. Look at the old prices. So look at the new prices and see how it changes. And EV will be same fixed to indifference curve. Look at the old prices. Okay, that's the definition. Okay, because these two can be different depending on shape. Okay. Now, how do we get that is basically based on Shapley's lemma, right? And because you can integrate, because you differentiate the utility, give you the because you extend demand, right? So it's basically just like we can integrate, right? That is the extend demand, right? But looking at the old utility level is the CV, EV will be the new utility level, right? So that is what it means, okay? And this turned out to be, if you forget the C, change to Y, that will be the consumer surplus, right? So you can write this up, the proof. The proof is like this. I'm not going to prove it, but basically from the definition here, you come to Shapley's lemma and just get it done, okay? But I'm not going to go to the math here, but turn out that the consumer surplus, which is defined this way, okay? If there's no income effect, okay, means Hessian demand equal to the Maxwellian demand. Whether you call CV, EV, or CS the same thing. Okay, but if there Hicks income effect, I'm not going to prove it. Depend on your good, is normal good or inferior good. Okay, if normal good, the EV bigger than CV, CS in the middle. If inferior good, that would be that. Remember, normal good means the income effect positive. Inferior good, income effect negative. The proof is just from this lucky equation, or you can draw a graph. I'm not going to talk about those because I guess none of you are actually going to differentiate that. But I want to tell you that what is important in your mind is CS is accurate, it's a good measure, although it has no foundation yet, right? Because based on you integrating some consumer surplus, right? But it's not actually well-founded, right? It's not the money compensates something, right? You integrate certain thing, seems to work, all right? You never tell the foundation. But now we tell you that depend on your inferior good or normal good, right? Your welfare measure is either CV or EV, depends on the perspective. And CS is turned out to be in the middle. Okay? So that's why CS is a good measure. There's a graph to explain why this is true. Do I have time? maybe I explain one graph because I spend so much time drawing this graph. So it'd be good to have time. Maybe I explain one, hopefully. If I explain this, I have to explain this guy first. Maybe I explain this guy first, okay? So this is a comparison of the Hicksian demand and the Marshallian demand, which underline this Slutty equation. Then I can go to explain the CBA, okay? First, this is the black one is the Marshallian demand, normal. So that's a thing you learned in the Microeconomics 101, okay? And the Hicksian demand can be in this shape or in this shape. Depend whether it's normal good or inferior good. Okay. Why? Why the normal good? Because normal good means what? Income effect is positive. Okay. And your price go down, you have more money. Right? So the income effect is positive. Is that clear? The difference between the two lines is the income effect. Right? Because the Hicksian demand, it just have the substitution. Right? Which is always downward sloping. And the Marshallian demand will be Hicksian demand plus income effect, right? Because normal good means that you have more money, you spend more, right? You have less money, you spend less. So that's why once you have the Hicksian demand, which is always downward sloping, as we argue, right? When you draw the Marshallian, it will be like this. And if for inferior good, it will be like this one. Why? Because when the price goes down, you have more money. Because inferior, you don't want to spend that much, right? For example, what is inferior good is 2-dish rice, 两菜饭, right? If your money, you don't want to spend that, right? You want to spend your money on a hotel, on a 5-star hotel buffet, right? So then you have more money, right? You're getting cheaper, you have more money, then you will spend less, right? That's how if you go more expensive, you have less money, you spend. That's the distinguished Hicksian and Marshallian demand. Okay. The addition is the income effect, right? This is a Slutty equation in graph. And now I think we can explain how the CV and EV. Okay. Now we focus on the case where normal good. Okay. Normal good is, suppose this is the Hicksian demand, right? And normal good, Marshallian demand like this. Okay. Now suppose price one changes. Okay. What happened when you draw the Hicksian demand? Sorry, the Hicksian demand under a another utility level, which is at lower price, right? Then it's higher, it will be on this one. Okay. First, this is the price, it's here. And the price lower, the Marshallian is here, right? And the Hicksian will be here. Right? First, this is the case because it's normal good, right? And when you look at the EV, right? EV is what? Looking at the new prices. This is area. And CV will be this area. And CS will be this area. CS will be this one. Let me use the green color. The CS will be this area. This is CS. A changing control surface. Okay. So you're going to Marshallian, look at this area, right? And if you use the EV will be the red one, and the purple one will be the CV. And usual case we use is the green one, right? Because you can, this is our construct. And probably ask why we do that, because in theory, it's very difficult to do the EV and CV calculation. and CS is very easy to do. Okay, so since they're in the middle, I mean, we don't want to choose side, so why don't we use consumer surplus? Easy to calculate, right? And that tracks one way or the other. Okay, is that okay? So I hope I give you the idea why this is true. I have the normal good, and then you can do the inferior good. I think the same graph by yourself. I put it here, but you will see the same. Okay, this explains why in this case CEV is better than the consumer surplus, is bigger than the EV. Okay, this is proof. Of course, this is not a serious proof. You have to do the math. You don't want to do serious proof, but the real proof is not too much different from the graph. Anyway, just things getting more formal, but that's the idea. Is that okay? Okay. So another good sign is, which we like, is when they're very similar. Turn out to be, if the pricing is small, they're the same. So we're happy, right? Unless we talk about very big price changes, CV and EV and C are the same. So we're happy. So there's no conflict in our mind, because whether you like CS, whether you like EV or CV, there's no difference. The same thing. So as long as the pricing is small enough, done. Of course, the proof requires Taylor approximation. You should look at the book. But that means that everything is nice, right? Because we learn undergrad, right? We learn CS. That's a nice thing. That's nice intuition, right? Because we talk about the Marshallian demand is we need to pay, right? Right? But now we have everything here nicely done. Is that okay? So maybe let us review what we have done, because we've done the topic 1, right? So far we have done a consumer problem. But we start with consumer, with preference, with utility function. We have go very carefully how preference go to utility, right? And then the problem will be the tools. There's a two sides of the same coin, as a utility maximization problem or expansion minimization problem. And these two problems give you 4 different solutions, right? One is Marshallian demand, one is indirect utility function, one is Hicksian demand, one is exponential function. You will use 4 of them, actually depend on data, what data you have, right? Or what theorem you want to prove, which one is easy. And then after that, we learn how to calculate welfare, which is very important when we talk about policy, or you want to measure business decision, right? Because at the end of the day, right, if consumers not happy, then probably they will go to other company, right? There's a reduced form modeling, right? Because suppose you want to implement a new changes to your policy, you want to keep them as same as happy before you're not happy yet. Otherwise lose to other customer, to your competitor, right? So if you want to have a reduced form modeling, you model the consumer surplus, you want to make some changes to your program or your product make sure that the consumer surplus remain the same, so that they still keep in your loop, right? So that is the idea. Okay, I hope I illustrate what we want to do. I mean, we skip many slides. It's a normal in all the PC classes, but as I said, for your assignment, for your exam purpose, remember the red box and you're done. This is what the assignment and the thing do. Of course, when we do projects in your future, you need to refer to what we have been doing, but otherwise, you don't need to worry too much about that. Okay. If no question, then we'll go to topic 2. I'm pretty sure that you allow me to do it. But we just give you a very brief overview, because I think after 3 hours, then you are very tired. At least I give you some idea to what we are doing for the next class. Okay, producers, okay, or you can say firms. Okay, let me give you what we are doing for the firm. Since we're in B school, the question is, why is the firm, right? And people will do corporate finance. In the finance, then you will see that what we are doing is very simple. The firm here is a black box. just doing one thing, profit maximization. And many of you do corporate finance or management organization would disagree, because within the firm it's so complicated, right? But we can't use the standard microeconomics tool to study firm, because this idea of the field of firm is one said by the Ronald Coase is firm is suppression of market, right? There's a limit of firm. Why we market is so good? Later we will learn in the next topic. Topic 3 is welfare theorem, is market works nicely, miraculously. The first question is, why we are firm at all? Why be split at all? Why everything doesn't in the market? Right? That's the first question asked by Ronald Coase, right? The field of firm. Why we have firm? Why firm will exist? Because if everything is done nicely by the market, we can just buy and sell. There's no need to a firm, right? But on the other hand, this firm is so good, why need market? Why just single big firm do everything, right? And there must be some limitation on the firm, right? And what Ronald Coase, which is also Nobel Prize winner, right? If you know where, is the famous sentence is, I think some paraphrase is, firm is suppression of the market, right? Within the firm, you're not talking about market, right? Your boss don't ask you to do this, I pay you this. The boss tell you do this and you do it, but there's no market, right? Exactly, the firm is exactly opposite the market. So, but we have to see, actually it's a big thing in organization economics and also in management, right? Where does it end, right? Why don't firm expand as many as they want, right? If command is so good, right? Because firm is just command, right? The boss tell you this and you do, right? And why there are more than one firm? Why the supply chain don't integrate each other, right? We don't talk about that because it requires us game theory. The modern tool to study how within firm work and between firm is require game theory. And the classical thing we do is still rely on market. Okay? After we understand market, then we understand the boundary of firm, right? Until at what extent firm can do, right? And firm cannot do. Okay. But anyway, let's assume the firm is a black box. Okay. They just do profit maximization. Okay. And then we will see how this thing works. Okay. We will follow our tradition of consumer. We study in detail from the very basic how firms create profit. Okay. They create profit by producing something, right? So that's why the crucial part is production technology. Okay. Same as preference, right? We are able to rank stuff, right? People are basically, we are going given the bundle. Utility tell us how the bundle convert into some number, which is utility, right? Here the same. We will tell us how input can be converted to output. That is called production function. Okay, let me repeat the parallel. Consumer take consumption bundle, goods, commodity, and convert it in your utility in your head. There's a number there. Firm taking some input and convert to output and sell in the market. Okay, assume that market exists to buy your product. Okay, it's price taker. Okay, consumer can always buy as many as they want, as long as the money. Same firm can sell as much as they want at the market price. Okay, we make a lot of assumption here, but that is what being true. And probably you ask, why this is there? You have looked at econ history. Okay, when economics being formed is during Industrial Revolution, right? At that time, firms are small. There are not too much big firm there, right? And market is very competitive, right? If you learn, conglomerate actually exists in the US in the 1900, right? When transportation being more convenient, right? Their economy of scale, and that come up with a rise of big firms, big conglomerate, and of course there's an antitrust regulation afterward. But before that, right, many firms are localized, right? They're in a small place, right? In a small area, right? There's no Taobao, there's no Alibaba in the global, in a country scale, right? Everything is city, very competitive, right? A small store. So that's why these models are satisfied for those needed. Of course, now globalization, thing changes, need a more complicated model. But these are still a baseline model where you can still trust it, and they still remain good model in many cases. Okay. And again, we have two types of problem. Okay. But they are not dual with each other. They would actually these two here will be, we're talking about a constrained problem and unconstrained problem. Okay. A cost minimization is a firm internally without considering how much they can sell. Okay. It's just saying that given the production technology, how I can convert input to output, how to optimally combine different input to output. So there's no market there. There's no profit there. It's a simpler problem. It's a easier problem to solve. Okay. And then problem maximization, okay, is a more complicated problem. Okay. We are solving the problem is simultaneously firm consider how can arrange its input to produce output and how much output to produce. Okay. So that means that this is a simplified problem. It's a full problem. So why economics introduced in this way? Because this will tell you how to solve problem in steps, right? We can solve a simple problem and look at how firms optimally behave, and then look at a full problem, which look at a much more richer environment. This also illustrates how you solve the problem, right? Because you can solve a reduced problem first and solve a complicated problem. And same as later you will see, we do game theory. We solve multi-stage game. We do backward induction. We start one stage, backward and backward. So the same idea here, right? We can solve a simple problem first. So that's why, although the problem you will see is very similar to the consumer, because same idea, right? Because also maximize some constraint. The math-wise is very similar, but we still do it because actually there are different perspective here, right? Tell you how you solve the problem step by step. Again, last with consumer surplus, turn out to be nothing new here. Consumers produce surplus, it's just profit. Okay, so that's very easy. Okay, is there any question? Although I have 5 minutes, I think I still can introduce some terminology before we go. You can see a lot of things here, but don't worry, it's not something complicated. Okay, first, probably I'll end up with this slide, which you agree or may disagree. Okay. As I said, firm, we assume a black box to be profit maximizing. Okay, and this would fit, I think, 90% of the paper in the literature. The remaining 10% will not assume that. Okay, they assume there are many different type of objectives. Okay, first, why you would want to maximize profit? Because it's easiest. Okay, and Milton Friedman argue why firms would have other objectives. You should have one objective: maximize profit. Suppose the shareholder has objective more than profit, say there's CSR concern or ESG concern, right? But Milton Friedman would say, okay, if you have that, you can do it on your own. You don't need the firm to do it, right? If you want to do charity, okay, as a company, then why don't you use the shareholder do charity by themselves? Why you have to delegate this task to the manager, right? Manager is not, they're good at business, they're not good at doing CSR, ESG, right? Of course, you know there's some friction, so that's why maybe you need CSR, ESG. But anyway, but that is what the argument. Okay. The second is, you may consider firms should be care about consumer. Okay, right? Because firm, they care CSR, right? Consumer is important, right? They cannot extract as many as they want. Or firms should be care about labor union, right? Which is actually the case in Germany. In Germany, when you talk about production, you talk about wages, you have to talk about total labor union. If labor union disagree, they are not happy, you cannot do things. Okay, you have the new plan, you have to make sure the labor union are not upset. Okay, or people these days talk about stakeholder, not shareholder, right? You have to make sure everyone is happy, right? or ownership is important, or management is important, right? Because the firm may be government owned, they call mixed firm. But there's some paper talk about mixed firm is it's government owned, they don't maximize profit as well. They will maximize profit plus some fraction of consumer surplus. That's why we learn consumer surplus as well. They're called mixed company. And that paper talk about how things changes when the firms are public company or the mixed ownership, right? So these are the things that can be variation, right? Or these days, in many paper, there's some paper talk about interlocking management or jointly owned common ownership, right? Because if you look at finance and many top company, big company are actually owned jointly, have the same shareholder, say BlackRock's, right? Or big pension fund actually own multiple company. They're competing, right? And how these things change their behavior will be another issue. Okay. So, but in the basic thing, we focus on profit maximize, right? And in game theory, okay, sometimes you may want to maximize shares. Why? Suppose two-stage game, okay? Consumer may log in. Log in means that they are loyal to, suppose they buy your product in the first round, they're more likely to buy you second round. In that case, people may behave as if the firm in the first round maximize the share, right? You reduce the price to very low, everyone will got your product in the first round. Second round, they will charge more, right? So if that case, the first round, they may not be maximizing profit. So they may maximize their market share. So that's why sometimes they model it as a market share optimization. They're maximizing the market share in the first round, period one, period two, maximize profit. This is also possible. Okay, you can do that as well, but that becomes a behavioral model, not a standard classical model. Okay, because you are making some behavior assumption there. But that's also doable in certain kind of business setting. Okay, but in our class, we will limit ourselves on the standard one. Okay, we'll continue our journey, not next week because of I think next week we have a Happy Moon Festival, Mid-Autumn Festival. So in that case, maybe I can release the first assignment, ask you to do something, maybe just one single question, to make that one single question to just ask you to derive give you some utility to derive something very similar to what we do, and then since you have a holiday, right? So just do something to maybe you should spend less than half an hour to finish that assignment. If you spend more than half an hour, then you have some trouble. Okay, that should be easy. Okay, so I will see you the week after. You can tell me whether you want to make up the class sometime, but if you don't want to make up, it's okay. It's perfectly fine. But anyway, I'll see you the week after. Don't have too much mooncake. Have some is okay, not too much. See you next time.